Dear students, in previous video I have discussed about the Newton's laws of motion, that is part 1, and in that video I have already discussed some cases, some applications of Newton's laws of motions, and in this video I will discuss about some more cases of Newton's laws of motion, and I hope that these videos are beneficial for you and for your study. And if you feel any doubt and any confusion, you can write us. So in this video I will discuss about the some cases of pulley and some cases of pseudo force and some cases of weighing scale in which we can apply the Newton's laws of motion. So in first case I will discuss the case of a pulley. Suppose this is a rigid place and this is a pulley hanging on the rigid place. A weight mass M is hanging and it is balanced by a force F. So in this situation we can write F minus mg, weight due to this mass M, it should be mg. So force F minus mg, and it should be equal to the mass into acceleration. And in another case we can take, suppose this is a triangle and a pulley, this is a pulley and a weight is in this direction and a weight is in this direction. This is one weight and this is another weight. We can consider M1 mass and we can consider M2 mass, and this is 30 degree and this is 60 degree. So in this case, suppose this is A, this is B and this is C, and if I will discuss about AB, so it should be 30 degree, mass M1, and due to this string tension should be in this direction, mass should be downward direction M1G. So there should be a component in this direction and there should be a component in this direction. This angle should be 30 degree. So this component should be M1G cos 30 and it should be M1G sin 30. It should be M1G sin 30. So equation becomes M1G sin 30 minus T equal to M1A. This is equation number 1. And suppose we will discuss the case of BC side. This is the case of side AB. This is the case of side AB. Now we will discuss the case of side BC. In BC side, we can take, suppose this is BC side, this is a mass M2, 60 degree, M2G, tension in this direction, M2G should be M2G cos 60 and in this direction it should be M2G sin 60. So I can write T minus M2G sin 60, it should be equal to M2A. This is equation number 2. So by the help of these two equations we can determine as the parameters asked in the question. So now I will discuss the third case. Weighing machine. When we measure the weight of a person, then weighing machine does not measure the actual weight. It actually measure the normal force on the person. Suppose we take the case inside the lift. Motion in a lift, and lift is unaccelerated moving. If lift is unaccelerated moving, suppose this is a person, then normal should be worked in upward direction and said weight would be acted in downward direction. Then if the lift is moving unaccelerated either in upward direction or in downward direction, then the weighing scale measure the actual weight, as normal is exactly equal to the weight of the person. But this is case number 1. But in case number 2, when lift is accelerated upward, then it means, suppose this is a person and normal is acted in upward direction, weight of the person is acted in downward direction, and due to the upward acceleration, MA is also acted in downward direction. So normal force should be balanced by weight of the person mg and force ma, or we can say N equal to mg plus a. So in this situation, the weight which will be measured by the weighing scale, it will be increased. And third case will be when the lift is accelerated downward. If lift is accelerated downward, then in that case, suppose person normal is acted upward direction, but if acceleration is downward, then MA should be in upward direction and weight is always acted in downward direction. So N plus MA, these forces are in upward direction and these two forces will be balanced by the weight of the person mg, or we can say mg minus ma or mg minus a. So in this situation, the weight which is measured by the weighing scale, it will be decreased. But in case of free fall, number 4, in case of free fall, suppose lift is free falling or person free fall in downward direction, then in that situation normal becomes equal to 0, and if normal becomes equal to 0, then person will experience a state of weightlessness. In this condition, the person feel the situation of weightlessness. So now we will discuss mechanical advantage. MA, mechanical advantage. Mechanical advantage is basically the ratio of load and effort the ratio of load and effort is known as the mechanical advantage. And we can understand it by an example. Suppose this is a inclined plane at an angle theta. This is a body of mass m. A weight is acting in downward direction. A force F is applied in this direction, and if this angle is theta, then this angle should be theta, and this component should be mg cos theta, and this component should be mg sin theta. So mechanical advantage, it should be load upon effort. So load is mg, and the effort which is working on the body, that is mg sin theta. As mg sin theta is balanced by this force F, so effort is mg sin theta. So mg upon mg sin theta, that should be the mechanical advantage, and we can say mg cancel out, 1 upon sin theta or cosec theta. So in this case, the mechanical advantage should be cosec theta. Now we will discuss a case which is shown in figure. That is a figure. A block, this is 2 kg, is tied by the string, this string and this string, and by the help of this pulley, again a body of P is hanging, and this pulley A, this is a pulley A, and this is a 2 kg weight hanging by the help of this pulley A. The angle of inclined plane is 30 degree, and we have to determine the mass of block P, so that the system remains at rest. And also we want to determine the force exerted by string on the pulley B. This is the pulley B, and we want to determine the force exerted by the string. So in this case, we can say that if we discuss this block 2 kg, this is 2 kg, it means weight, it should be 2 into g, downward direction, and it should be balanced by the tension acted on the string. So it is balanced by this T. So T should be 2 into G. G, if we take 10, then it should be 20 Newton. 20 Newton, this is the tension by the string which acted on the pulley A. Now we will work on this 2 kg block, and this is inclined plane, this is 30 degree, and this is a block. Weight should be 2g in downward direction. It should be 2g cos 30. It should be 2g sin 30. And suppose tension T dash So if we see the diagram, 2g sine 30 and tension which is acted due to in this direction. So 2g sine 30 plus t, it should be balanced by t dash. It should be balanced by t dash. So t dash becomes t. We have already calculated 20 plus 2g 10 sine 30 1 upon 2. 2 cancel out. 20 plus 10 30 Newton. So T dash which will work in this direction, it should be 30 Newton. So now we will work on this block P. So this block P, it should be, suppose this is a block P, this is P, T dash, direction of T dash this, and it should be balanced. Suppose mass of the P block is MP into G. So T dash should be MP into G, and MP, it should be T dash upon G. T dash we have calculated 30 Newton upon G 10. So it should be 3 kilogram. The mass of this block, it should be MP equal to 3 kilogram. Now we have to determine the force exerted on this pulley B. So we know that tension in this direction it is T dash, again it is T dash. So we can draw the diagram. This is pulley, force, reaction are in this direction, and string, this is string, T dash, angle 30 degree, So reaction should be R, it is balanced by 2T dash cos 30. Component of this T dash in this direction, T dash cos 30. Component of this T dash in this direction, again T dash cos 30. So it becomes R equal to 2 T dash cos 30. 2 T dash is 30 Newton and cos 30 is under root 3 upon 2. 2 cancel out. 30 into under root 3 means 1.732, or we can also write 30 under root 3 Newton. This is the reaction which will work on the pulley due to these two tension of the string. So this is the combined problem in which we have discussed about the tension due to the string and also the normal. So dear students, we should also practice of these type of questions, and in next video we will also solve some more problem. And if you feel any doubt, you can write us and we will try to solve the problem. Thank you.